Hello everyone. In the last class, we learned how to solve differential equation of order n. So the first step, so we can have a quick review here. When we solve like differential equation, homogeneous differential equation, we find the PR, we try to solve for r equals 0, right? And then when r is real, okay, and then when r is complex, okay, we have several solutions. So when it's real, for example, if it's r minus 2 to the fourth equals 0, so the solution should be e to the 2x, x e to the 2x, x squared e to the 2x, and x cubed e to the 2x, right? When x is real. For r is complex, so when r is complex, what's our solution? So it depends on multiplicity. Okay, depends on multiplicity. For example, if r minus a plus bi, okay, for example, if this is square, a plus minus bi square, so we are going to have like e to the ax cosine bx, e to the ax sine bx, but because some multiplicity is 2, so we need to x e to the ax cosine bx and x e to the ax sine bx are the solutions. So today we're going to continue to use this method to solve more general differential equations. Let's take a look at example 4. Determine the general solution to just find general solution to this differential equation. So it's going to be third order differential equation. 2y second derivative 3y prime plus 2y equals 0. Same thing, the first step. So here is our PR. So let's take a look. R cubed plus 2r squared plus 3r plus 2. Okay, and this, it's a little bit tricky when we factor this out. Don't worry about this kind of problem. In the future, if we have complicated polynomial, I will give you the factored like polynomial. Okay, so the factor, the polynomial equals this one. And after we solve for this equals 0, okay, we get those r's. R1 equals -1. And R2 and R3, they will be this like a complex number. So if we solve from the quadratic, second quadratic part here, it's going to be like -1 plus minus root of b squared minus 4ac. Okay, see, sorry, here's 2, positive 2, minus 4ac. So going to be -1 plus minus root over 7I over 2. Okay, should be this. That's the solution for second part. So what's the general solution then? We can write down our solutions. y1 equals the real part, -1x, and y2, which is e to the real part, which is -1/2 x, right? And the cosine bx, b should be root 7 over 2, and the y3 should be e to the real part -1/2 x times sine root 7 over 2x, like this. So what's the general solution? Just the linear combination. So the general solution is just a linear combination of those three solutions: c1y1 plus c2y2 plus c3y3. Now let's take a look at the exercise problem. This is a pretty easy one, okay? We can factor this easily. So let's see, PR should be r to the fourth minus 16 equals 0. Factor this out, r squared plus r squared, so should be this one. Yeah. Okay, r squared plus 4 times r squared minus 4. Is that right? Okay. Think about this one before when we solve this, how to factor r plus 4, r minus 4, right? And here we just looked at r squared equals 0, and further factor this out. R plus 2, r minus 2. You can see for this, PR, we can find the solution now. So R1 should be 2, R2 should be -2. Those we have two real R, right? And then for this, we have complex. R equals plus minus square root of 4, which is 2i. So R3, R4 are conjugate, plus minus 2i. So now let's take a look at the solution. General solution, we should have y1 equals e to the 2x, y2 e to the negative 2x, and y3 should be e to the ax. What is a? The real part for this R3, R4. A should be 0. Is that right? So 0 times x, actually it's going to be 1 later. And the cosine 2x, y4, which is just 1 times sine 2x. This actually is 1. So what's the general solution? C1 e to the 2x, C2 e to the negative 2x, C3 cosine 2x, C4. Now let's take a look at example 5. We want to find the general solution to this differential equation. So let's see. Find general solution to this one. So differential equation is given by this way, operator way. So d minus 3 times d squared plus 2d plus 2 squared y equals 0. So this is the operator way, right? So how to solve this differential equation? We just do the same way. Like we find the PR first, r minus 3, r squared, 2r plus 2 squared. So here we need to just replace all the d by r and make this equals 0, solve for r. For this case, we noticed we have one real number, which is 3, right? And R2, let's see, which is going to be complex number, 2, negative 2b plus minus b squared minus 4ac. So it's going to be negative 2 plus minus root of negative 4 over 2. Simplify. 2i over 2, so it should be negative 1 plus minus I. So what are general solutions then? Let's write down. E to the 3x for the real r, right? And for the complex y, so it should be e to the negative x cosine bx, and we said cosine bx and sine bx, they always like a pair. But for this one, let's take a look at this power. We have power 2 here, multiplicity. So that means we should have 2 more solutions. They should be x e to the negative x cosine. Oh, sorry, I shouldn't write down bx. B is also 1, so just write down x here. Okay, cosine x, and we have another one, x e to the negative x sine x. So the general solution is just linear combination, c1 e to the 3x, c2 plus c4 plus c5 x e to the negative x sine x. Okay, so this is the general solution. And we can try this exercise problem. D squared plus 4 squared times d plus 1 y equals 0. So here's the solution. Interesting. For this one, we should have r equals plus minus 2i. Is that right? Because it's plus 4. Okay, plus 4. And we should have r equals negative 1. Then let's write down the general solution. So the solution should be e to the negative x. I always like to write down the real in front. I'm going to write down, okay, and the c2. So here, real should be 0, real part. So e to the 0 is 1. So just cosine 2x, sine 2x. And because its multiplicity is 2, so here x cosine x, x sine x. Okay, that's the general solution. Let's see, we can continue to do more examples. Example 6, the last one. Solve this differential equation. So you can see getting much larger, right? So the order, like here should be order 5, 2, 4, 7, order 11. Okay, so should have 11 solutions. Now let's see, corresponding to the first one, R should be what? 0. Is that right? And then R equals 2. Multiplicity is 2. And then R equals plus minus I, M equals 2. Now let's see, corresponding to those R, what's our solutions? I'm just going to write down after each R. So the first one should be e to the 0x. Is that right? So what is the e to the 0x, which is 1. And the next it should be x times e to the 0x, so which is just x. And then multiplicity is 3, so the next one should. Let's see, for r equals to 2, we have solution should be e to the 2x, x e to the 2x, because the multiplicity is 2. And next, same thing, real part is a is 0, so it's just cosine x, sine x. And the multiplicity is also 2, so we should have x cosine x, x sine x. So those are all solutions. The general solution is going to be just linear combination. C1, C2x, x squared. Just write down all those linear combination. C5, C6, cosine x, C7 sine x, C8, C9 x sine x. Okay, so this is like the example 6. Let's try this exercise problem. So here's the solution. Let's see. Corresponding to r equals 1, we have 3 solutions. And corresponding to the complex 3i, we have 2 solutions, cosine 3i and sine 3i. So general solution is just this combination of all those. Okay, so here's the solution. So that's all we need to know for this section. We just need to know how to solve differential equation of order n with constant like p d y equals 0. So summary.